Good morning, students. Welcome to Bindu Dhadwal Chemistry Lessons. Today we'll be doing exemplar problems on the chapter Solutions. Which of the following units is useful in relating concentration of solution with its vapor pressure? According to Henry's law, the partial pressure of a gas in the solution is proportional to the mole fraction of the gas in the solution. P is equal to KH into X. So vapor pressure can be related to this property, mole fraction. So option A is the correct answer. On dissolving sugar in water at room temperature, solution feels cool to touch. Under which of the following cases dissolution of sugar will be most rapid? As it feels cool to touch, the reaction is endothermic. Procedure will be more rapid if the reaction takes place at high temperature. Also, powdered sugar will have greater surface area than sugar crystals. So, powdered sugar in hot water is the correct option. The dissolution will be more rapid in this case. At equilibrium, the rate of dissolution of a solid solute in a volatile liquid solvent is equal to the rate of crystallization, because at equilibrium the forward reaction is equal to the backward reaction. Forward reaction is dissolution and backward reaction is crystallization. At equilibrium the rates of the two are equal. A beaker contains a solution of substance A. Precipitation of substance A takes place when small amount of A is added to solution. The solution is supersaturated. Substance A will not dissolve if the solution is saturated, will dissolve if it's unsaturated, and it will precipitate if it's supersaturated. So B option is the correct answer. Maximum amount of solid solute that can be dissolved in a specified amount of a given liquid solvent does not depend upon the pressure, because the solid and the liquid solvent both are incompressible. So increase of pressure will not compress the liquid or the solid, and so the dissolution will not be affected. Low concentration of oxygen in the blood and tissues of people living at high altitude is due to low atmospheric pressure. When the atmospheric pressure is low, the oxygen from the blood will be released, resulting in low concentration of oxygen in the blood. Considering the formation, breaking and strength of hydrogen bond, predict which of the following mixtures will show a positive deviation from Raoult's law. So option is methanol and acetone, because methanol molecules are joined to each other by hydrogen bonds. When acetone is added, these molecules come in between the methanol molecules and break some of the hydrogen bonds, because of which the interaction between the two solvents decreases and vapor pressure increases. So it shows positive deviation from Raoult's law. The other mixtures show negative deviation from Raoult's law. Colligative properties depend upon nature of solute particles dissolved in solution, number of solute particles dissolved in solution. So it depends upon the number of solute particles in the solution. Which of the following aqueous solutions should have the highest boiling point? 1 molar NaOH, 1 molar sodium sulfate, 1 molar ammonium nitrate, 1 mole KNO3. As we know that the elevation in boiling point delta TB is equal to Kb into M into Van Hoff factor I. Now, as the concentration molality is same and the solvent is also same, the elevation will depend upon the Van Hoff factor. Van Hoff factor for NaOH is 2, for ammonium nitrate is 2, for KNO3 is 2, but for sodium sulfate is 3. So elevation increases with sodium sulfate because the Van Hoff factor value increases. So highest boiling point will be of sodium sulfate. Option B is the correct answer. The unit of ebullioscopic constant is, again, let's write the formula for elevation in boiling point. Delta TB is equal to Kb into m. So Kb will be delta TB upon m. Elevation is measured in Kelvin upon molality is moles of solute dissolved per kg. So when it goes up, it becomes mole inverse kilogram. So option A, Kelvin kilogram mole inverse, or K into molality inverse is the correct option. In comparison to a 0.01 molar solution of glucose, the depression in freezing point of 0.01 magnesium chloride solution is, we know that delta TF is equal to Kf into m into I. As the solute changes, glucose does not show any dissociation, whereas MgCl2 will dissociate into 3 particles, magnesium ion and 2 chloride ions. So value of I will be 3. With introducing 3 into this equation, this turns, elevation turns, a depression of freezing point turns higher 3 times. So the depression in freezing point is about 3 times. An unripe mango placed in a concentrated salt solution to prepare pickle shrivels because it loses water due to osmosis. Osmosis occurs where water from the mango will go into the concentrated solution by the process of osmosis through semi-permeable membrane. At a given temperature, osmotic pressure of a concentrated solution of a substance is higher than that of a dilute solution is the correct option, because osmotic pressure pi is equal to CRT. So as the concentration increases, the osmotic pressure also increases. Which of the following statements is false? 2 different solutions of sucrose of same molality prepared in different solvents will have same depression in freezing point. This is false because having different solvents will have different Kf values. So as you know that delta Tf is equal to Kf into m. So when the Kf value is different, the depression in freezing point will be different. The values of Van 't Hoff factor for KCl, NaCl and K2SO4 are respectively, we have to see the Van 't Hoff factor is 2 for KCl, 2 for NaCl and 3 for K2SO4 because number of ions furnished are so. So option B is the correct answer. Which of the following statement is false? Unit of atmospheric pressure and osmotic pressure are same. This is true. In reverse osmosis, solvent molecules move through a semi-permeable membrane from a region of lower concentration to a region of higher concentration. No, they move from a region of higher concentration to a region of lower concentration in reverse osmosis. So option B is false. Value of Henry's constant Kh increases with increase in temperature, decreases with increase in temperature, remains constant, first increases and then decreases. It increases with increase in temperature. The value of Henry's constant is greater for gases with higher solubility, greater for gases with lower solubility. It is greater for gases with lower solubility. Consider the figure and mark the correct option. So, fresh water and concentrated NaCl solution in what? Water will move from side A to side B if pressure lower then osmotic pressure is applied on piston B? No. Water will move from side B to side A if pressure equal to osmotic pressure is applied on piston B? No. Water will move from side B, to side A, if pressure greater than osmotic pressure is applied on piston. Yes, because reverse osmosis occurs in this case. So option C is the correct answer. We have 3 aqueous solutions of NaCl labeled as A, B, C with concentration 0.1, 0.01 and 0.001 molar respectively. Value of Van 't Hoff factor for these solutions will be in the order. It will be Van 't Hoff factor for A will be greater than that for B, than that for C, because concentration is greater for A. It is a measurement of total number of ions present in the solution. Greater the concentration, greater will be the Van 't Hoff factor. That's all in today's video. Thank you. Have a nice day.